SpaceX successfully launched an advanced GPS satellite for the U.S. Space Force on Thursday, November 5, marking the first launch in nearly 2 weeks here on the Space Coast. Running more than a month late after a Falcon 9 engine problem grounded the mission, the GPS navigation payload rocketed into a clear autumn sky on Thursday. One of the company's 2-stage Falcon 9 rockets blasted off from Space Launch Complex 40 at Cape Canaveral Air Force Station here at 6:24 and 23 seconds p.m. EST, 2324:23 GMT, carrying the GPS III-SV04 satellite to orbit. 9 minutes later, the rocket's first stage touched down on the deck of Course I Still Love You, one of SpaceX's 2 drone ships. After climbing away from Pad 40 at Cape Canaveral Air Force Station with 1.7 million pounds of thrust, the 229-foot-tall, 70-meter, Falcon 9 rocket headed northeast from Florida's Space Coast on a track parallel to the U.S. East Coast. The GPS III-SV04 mission had been set to follow on the heels of a United Launch Alliance, ULA, Atlas V rocket, which was scheduled to loft a U.S. spy satellite from Cape Canaveral on Tuesday, November 3. However, the Atlas V launch was delayed twice due to issues with ground systems equipment. ULA is now targeting Friday, November 6, for that liftoff. It was a crystal clear night here on the Space Coast, and onlookers were able to follow the rocket through the different phases of launch. A nebula-like cloud, typically visible on clear nights, formed around the rocket as the first and second stages separated. The booster's re-entry burn was also visible from a press viewing area. The Falcon 9's second stage ignited 2 times to maneuver the U.S. Space Force's 4th third-generation GPS satellite, designated GPS III-SV04, into an egg-shaped transfer orbit ranging in altitude between roughly 250 miles, 400 kilometers, and 12,550 miles, 20,200 kilometers, with an inclination of 55 degrees to the equator, according to publicly available tracking data. Those figures confirm the Falcon 9 rocket hit its marks before deploying the Lockheed Martin-built GPS III-SV04 satellite nearly 90 minutes after liftoff, wrapping up SpaceX's 20th successful mission of the year. Lockheed Martin confirmed in a statement that ground teams at the company's Satellite Control Center near Denver established contact with the nearly 5-ton GPS spacecraft, which will fire its onboard liquid apogee engine multiple times in the coming days to reach a circular orbit some 12,550 miles above Earth. Ground controllers will send commands for the GPS satellite to deploy its power-generating solar panels and antennas, perform checkouts, then hand over the spacecraft to the military's Space Operations Command. The GPS III-SV04 satellite will join 31 operational spacecraft in the GPS fleet, providing positioning, navigation and timing data to billions of military and civilian users around the world, supplying information to cell phones, cars, airplanes, and ships. The new satellite will complete its checkout and test program in about a month, and officials expect GPS III-SV04 to be ready for operational use in a few months, according to the Space Force. The GPS-3 program continues to make strides in modernizing the GPS constellation for the U.S. Space Force while maintaining the gold standard for position, navigation and timing, said Colonel Edward Byrne, Medium Earth Orbit Space Systems Division Chief at the Space Force's Space and Missile Systems Center. The GPS-3 series satellites are designed for 15-year lifespans, an improvement over the 7.5-year and 12-year design lives of previous generation GPS satellites. GPS-3 satellites provide a major step forward in both capability and resiliency compared to legacy GPS satellites, Byrne said. GPS is a critical enabler for the U.S. military and its allies, and provides worldwide service to over 4 billion civilian users around the globe. The first of 10 GPS-3 series satellites launched in December 2018, followed by 2 more GPS-3 spacecraft in August 2019 and on June 30 of this year. GPS-3 satellites provide 3 times better accuracy and up to 8 times improved anti-jamming capabilities over early GPS spacecraft, according to Lockheed Martin. The GPS-3 satellites also introduce a new L-band civilian signal that is compatible with other international navigation satellite networks, such as Europe's Galileo program. Combining signals from GPS, Galileo, and other navigation satellites can improve the precision of space-based position measurements. In September, Space Force officials announced they reached an agreement with SpaceX to launch future GPS-3 satellites on Falcon 9 rockets with previously flown boosters. The first stage booster flown on Thursday evening's mission will be refurbished and used again for the launch of the next GPS-3 satellite in mid-2021, officials said. The Space Force's Space and Missile Systems Center, or SMC, signed an updated contract with SpaceX in September to cover the agreement to fly the next 2 GPS satellites on reused Falcon 9 boosters. A reused Falcon 9 first stage will also launch the GPS III-SV06 mission, likely to fly in late 2021 or early 2022. The restructured contracts between the Space Force and SpaceX allowed for the landing of the Falcon 9's first stage booster after the previous GPS satellite launch June 30. SpaceX also launched the first GPS 3 series satellite in December 2018, but military officials required the launch company to reserve all of the Falcon 9's propellant for the launch of that spacecraft, leaving no leftover fuel for descent and landing. The Space Force relaxed their requirements for the next SpaceX launch with a GPS satellite earlier this year, adjusting the perigee, or low point, of the target orbit for deployment of the GPS payload to a lower altitude. That ensured the Falcon 9 rocket could land the booster on the June 30 mission, saving the Space Force several $1 million. Factoring in the changes to allow booster recovery on 4 GPS missions beginning with the June 30 launch, and then rocket reuse on 2 GPS missions beginning next year, the updated launch contracts between the Space Force and SpaceX resulted in $52.7 million in savings, officials said. The GPS III-SV05 mission next year will be the first high-priority national security payload to launch on a Falcon 9 rocket with a previously flown booster stage. Space Force officials will thoroughly review SpaceX's refurbishment and rocket reuse procedures and policies before clearing the GPS III-SV05 satellite to launch aboard a recycled booster next year. That will help lay the groundwork for launches of more national security satellites on Falcon rockets with reused first-stage boosters. This is our journey in understanding how SpaceX executes refurbishment of previously flown hardware, said Walt Lauderdale, chief of SMC's Falcon Systems and Operations Division, and the mission director for the GPS III-SV04 countdown and launch. We would then compare that to the qualification. It's learning and then assessing all the work that they do in order to get these boosters ready to fly again. So that requires review of a number of different systems and making sure that we're good across the board with previously flown hardware, not just this particular booster, Lauderdale said in a conference call with reporters in September. With the GPS III-SV04 satellite safely in orbit, SpaceX's next mission is the launch of the first regular Crew Dragon astronaut flight to the International Space Station, a blast-off scheduled for November 14 from Pad 39A at NASA's Kennedy Space Center in Florida. NASA engineers will analyze data from Thursday night's GPS launch to help ensure the Merlin engines are ready to go on the Falcon 9 rocket assigned to the Crew Dragon launch. SpaceX first tried to launch the GPS III-SV04 satellite October 2, but an engine problem forced an automatic abort just 2 seconds prior to liftoff. Engineers investigating the October 2 abort found that 2 of the 9 first-stage engines on the rocket had a tendency to ignite a split second earlier than expected. Inspections showed a blocked relief valve in the gas generators of the 2 engines caused pressures to rise sooner than designed at startup, and sensors on the engines detected the problem and halted the countdown. SpaceX engineers identified a masking treatment inadvertently left behind in two Merlin engines as the cause of the aborted countdown last month. Inspections revealed the substance blocking a line leading to a pressure relief valve in the gas generator on two of the engines originally slated for the GPS mission. Hans Koenigsmann, SpaceX's vice president of build and flight reliability, said the vent port, which means just 1/16 of an inch wide, was obstructed by a hardened masking lacquer. He said liquid lacquer, similar to red nail polish, is used by a third-party vendor that anodizes aluminium engine components for SpaceX. The lacquer protects certain parts during the anodizing treatment process, but the vendor, which officials did not identify, is supposed to remove the material before shipping the components to SpaceX for engine manufacturing. The gas generator on each Merlin engine drives a turbopump feeding kerosene and liquid oxygen propellants into the main combustion chamber. SpaceX replaced the two suspect engines on the Falcon 9's first stage for the GPS III-SV04 mission, then performed a test firing of the rocket Saturday on Pad 40 at Cape Canaveral Air Force Station. That gave officials enough confidence to proceed with the GPS launch countdown Thursday. A review of Merlin engines across SpaceX's rocket fleet found that two of the engines on the Falcon 9 rocket for the Crew Dragon flight were showing similar early startup signatures to the engines on the launcher for the GPS mission. SpaceX said last week it would replace those two engines on the Falcon 9 launcher for the Crew Dragon mission. The engine problem delayed the Crew Dragon launch from October 31 to November 14. Steve Stick, NASA's Commercial Crew Program Manager, said last week that the agency's engineers wanted to review engine data from the GPS launch before clearing the Crew Dragon for liftoff later this month.